Okay. Whenever you have a problem with multiple components, and do you see the multiple components?
Yes.
Right? There's a couple ways that you want to deal with this. Number one, you're probably going to want to isolate and observe one component at a time. It makes it much easier to figure out what's going on, because the reason you're freaking out is your brain is trying to do two things at once. It's trying to bring the ball down, bring the guy over, and how does that work? Do one thing at a time makes it much better. Secondly, usually when you deal with two sets of constraining variables, right, you want to find the bridge. What is the thing that connects them? Okay. In this one, what is the thing that connects these two situations? What is the quintessential variable that links this? Yeah, time, right? Does that make sense? Time? Because this guy has to time this correctly. He needs to make sure that the time that he releases this is the time it will take for this guy to get from some random point X to underneath him. Does that make sense? Okay, just so we kind of keep that in our heads. So let's take a look at the balloon guy first. So here's our balloon, and we know, what do we know? We know that this balloon is going to fall 10 meters. We know the acceleration of the balloon is going to be 10 meters per second squared. Wait a minute, you say. Hold on. Isn't it 12 meters? What did I do? I subtracted the height of the guy. Secondly, why is that 10 and not 9.8? Yeah, because I'm standing up here without a calculator. And if I round it to 10, it makes my life easier. When you are doing multiple choice tests, use 10. And then you will get an answer much faster. Probably not even needing to use a calculator. Okay, then, thirdly, why isn't this negative?
It's a positive acceleration.
Because I made that positive. You see that? So what have I done with my frame of reference? Yeah, I've oriented my frame of reference so that I get a positive acceleration by saying down is positive. Okay, any questions? Anybody confused? Have I shaken anybody up at this point? Yeah.
Wait, so you first start out with a negative.
Sorry?
You
Did I
first
start
start
out?
out negative because it's down. So you
Yeah,
start
yeah.
it,
Basically, I just said down is positive.
Because down is where it needs to go.
Right. In general, when I do kinematics problems, I find it's a lot easier just to use the initial direction of motion as positive. Do you have to do that? Absolutely not. I could make this negative 10. I could make that negative 10 meters per second squared. Everything will work out fine. It's just for me, it's kind of like whenever I see or visualize one of these problems, it's like I put my head like as the camera looking at what's moving. And so I make the direction of motion positive, everything goes away from my field of view, and then it just makes it easier for me. But you don't have to do that. All right, so what did we say the bridge was? Time. So we know that time is going to be important, right? Any hidden information here? Okay, this gravitational acceleration was hidden, wasn't it? I didn't tell you that. There's another piece of hidden information that I said was important. We don't know the time yet. I mentioned the other day when I talked about the 3 pieces of hidden information that are usually there. Camera, right? Tomorrow. Yeah. Camera? Oh, okay, I said it right. Yeah, for once. Okay, camera. What did you say? Yeah, initial velocity, right? Initial velocity is 0. So now I have x, I have a, I have initial velocity, I want t. So here, what I do is I use the kinematics equation that is familiar to us. This should have been in your notes. As a side note, I hope this records, we'll see. On the blog is this. This is your formula sheet. Print it, bring it, Tuesday. Okay, you are allowed to use this on your quiz and tests. Please notice, boom, there's our equation right there. How do I know to use this equation? Because it has x, v0, t, and a in it. And those are the variables that I have. So I flip back to here. What is my initial position? I'm going to say x0 is 0. Why did I say that? Because I'm using me as the center of the universe. And I'm putting myself as the guy who drops the balloon. So I'm making the balloon 0 at the top. So that goes away. Also, initial velocity is 0, so that goes away. So basically, I get t is equal to the square root of 2x over a. So I get the square root of 2, which is 1.41 seconds. So the guy in the house, or whatever, the apartment, has to let go of the balloon 1.4 seconds before the biker gets there. Am I done? No, I did not ask for the time. I asked for the distance. So we have another problem. So now we have Mr. Biker moving at 10 meters per second. I know that he's going to travel for a time of 1.41 seconds. The question is, what is his distance? I don't know. I'm stuck. Okay, let's take a look at the formula sheet. Do you see an equation on there that has distance, velocity, and time in it? Yeah, how about the first one? Right, the definition of average velocity. V is x over t. Well, we know that v is x minus x0 over t minus t0. Right? Well, in this case, what is t minus t0? What is this whole thing? That's 1.41 seconds. And then x0, we're just assuming that x0 is going to be like wherever this right here, this delta x, is going to be the distance the bike travels, and delta t is the time over which it travels. So we don't care which one's x, which one's x0. So then, from this, I can just say, if I call this delta x, it's going to be v times delta t. And our answer is 14.1 meters. And that is how you do that problem. See, so remember the steps. When you have a problem that has multiple components, don't immediately try to consider all components at once, right? First, consider one component at a time. Try to do out a problem, see what you can get. Even if you end up doing a couple of wrong calculations and coming up with stuff you didn't need, so what? Maybe you found the final velocity of the balloon right before it hit the ground, or whatever, who cares? The important thing is, isolate each one so that you can deal with it separately. Now, what you can do is isolate them, write down what you know, do your givens on the diagram, okay? Be careful, you don't like fall on the floor. Marching band last night, really? Yeah. Poor guy. All right, set up your problems and then go back and ask yourself, what is the bridge? What is the connecting factor between the two constraints of condition? Then you should be able to see what's going on. Because you see like, oh, I need time. Time gives me this, and then I can go over here. All right, questions? Alrighty then.